Welcome everyone. So today we're going to discuss about postulates of quantum mechanics. Postulates of quantum mechanics is built upon a set of postulates which are fundamental statements that are assumed to be true and from which the theory's conclusions are derived. Now, postulate 1. There is a wave function psi of rt. We can express psi of rt as psi, which is a function of x, y, z and t, which completely describe the space-time behavior of the particle consistent with uncertainty principle. And the postulate 2 that the dynamical variables which are the physically measurable quantities of the particle are represented by mathematical operators which are linear and Hermitian. That means from postulate 1 we can tell that there is a wave function associated to a particle which will describe the space-time behavior of this particle or the system, and for these particles there will be dynamical variables which will be linear and Hermitian. From postulate 3 we get the concept of eigenvalue and eigenvalue equation. If this system, quantum mechanical system, is in an eigenstate A, then if we do any measurement on this quantum mechanical system, we will get the value of eigenvalue which is A. That means these dynamical variables take quantized values in quantum mechanics. Postulate 4. Postulate 4. If a system is in a state described by the normalized wave function psi, then the average value of the observable corresponding to a cap is given by this expression. Here a cap is the observable, then its average value can be written in this way, that integration minus infinity to plus infinity psi star a cap psi d tau. So from postulate 4 we get the concept of average value of the observable a cap. Postulate 4. The wave function of a system evolves in the time according to the time-dependent Schrodinger equation, that is h psi of rt is equals to I h ka del psi del t. So this is the expression for the time evolution of the system. Okay, so from postulate 5 we get the concept of the evolution of wave function, how the wave function evolves with time. That will tells us the postulate 5. Now let's see the postulate 6. The total wave function must be antisymmetric with respect to the interchange of all coordinates of one fermion with those of another. Electronic spin must be included in this set of coordinates. So that means the wave function is antisymmetric in case of fermions. So this was the postulates of quantum mechanics. These postulates help us to understand the behavior of a quantum mechanical system, how the states of a quantum mechanical system is described, how the measurement affect these states, and how these states evolve with time. All these things can be clearly understand with the help of these postulates. So this was our discussion on the postulates of quantum mechanics, and on our next class we're going to discuss about 1D potential barrier. Thank you everyone.